Towards Green Energy in Science 2, which is chapter number 5 in the textbook. Also, this happens to be the 5th chapter that we are studying in Science 2. This is a very interesting chapter. Interesting in the sense that it is connected to something what we have studied in Science 2, something that we have studied in Science 1. It also has some mathematics, very little, just one bit of mathematics, and it also has some very real life examples, application of science at a very small level, also at a very big level. Yeah. Let's see what this chapter is about. Do you remember what these icons are, what these symbols represent? We came across these symbols earlier in science. I don't remember whether we came across these in Science 1 or Science 2. If you know, speak up. If you know, type. On the, both are green. Both the symbols are in green. And on the left hand side, we have a leaf. Then there is a wire connecting to a plug. Yeah. Usman is saying solar save electricity. And Prachi saying number 2, second one on the right hand side is about solar energy. Aarti Bania saying it is solar panel. Yes, Rahul, speak.
It is renewable energy. It is renewable energy.
Okay, it is about renewable energy. Renewable energy is something which can be renewed again and again. It can be recycled. It can be reused again and again. And also it is something that is unlimited. That is unlimited. Karthik is saying number 2 is solar energy. Alfia is saying number 2 is save electricity and solar energy. And Khadija says the first one is about saving electricity and the second one is about solar energy. Aarti is also saying the first one is about saving electricity. Correct. And as I said, as both are in green. And remember, the one of the words in the current chapter is green. And Rahul pointed out it is about renewable energy. Thank you, Fiza. Saving energy. Do you remember these? What is the symbol on the left hand side? What is the symbol? What is the diagram on the right hand side? There is a diagram on the right hand side, and Rachi says it's Fleming's right hand rule. Yes, it is about right hand. It is Fleming's right hand rule. And Khadija says the second one is a DC generator. Really? Is it a DC generator? No. Something is wrong in the answer. Aarti saying first one is Fleming's right hand rule. It's Fleming's right hand. No, it is someone's right hand, but it represents Fleming's right hand rule. Karthik is saying second one is generator. Be more specific, Karthik. Khadija, now you are correct. Prachi, you are correct. On the right hand side, we have the AC generator, right? So Fleming's left hand rule tells us the direction of the current when the current is induced in a conductor because of the change in the magnetic field around it. We have studied this phenomenon as electromagnetic induction. Electromagnetic induction. And all these things that we have already studied, they come together in this chapter, which is called Towards Green Energy. Once again, before we move from this slide, the moment you see two rings in a motor or a generator, if you see two separate full rings, that means it's an AC device. If it is a motor, it will be an AC motor. If it is a generator, it will be an AC generator. Instead of two complete rings, if you see two half rings, which are called split rings, it will be a DC device. If it is a motor, it will be a DC motor. If it is a generator, it is a DC generator. And how do we know whether something that we are seeing is a generator or motor, we have to look at the bottom. What is connected here? The device that we connect, or that is connected here, is to detect the current or to measure the current. That means current is being produced. So this is a generator. In case of a motor, we will not connect a device here. We will connect a power source, whether it is a direct current power source or a alternating current power source. Never get these wrong. Always get these right. Rings will tell us AC or DC, and what is connected to the circuit will tell us whether it is a motor or a generator. If that is the case, if these are the two things that I'm reminding you, I'm asking you, then what do you think we are going to study in this chapter? If you have looked at the chapter, then you already know. If you have not looked at the chapter, make a guess about the questions that we asked now, the things that we revised now. Chand is saying we are going to study about energy. Okay. The name of the chapter is Towards Green Energy. Prachi is saying generating renewable energy. Okay. And good. Between Rahul and Prachi, you have reminded me to use the terms correctly, and I will tell you what is the how we are using something wrongly and what should be correct. Chan says we will study about energy, and Prachi says we will be studying about generating renewable energy. Okay, so the connection that I would like to make is the correction is we will not say that energy is renewable or not, because we know that energy can neither be created nor be destroyed. It can only be converted from one form to another, right? But what is renewable and what is not renewable is source of energy. Some sources of energy are renewable and some sources of energy are non-renewable. For example, fossil fuels, petrol, that is oil, coal, and gas. They are non-renewable sources of energy because their supply is limited. Whereas the sun is a renewable source of energy because for all practical reasons, sun will always be there. Technically speaking, that is not true. Sun will also die someday, but that will happen much after a very, very long time. That is why I said for all practical reasons, we can say that solar energy or the sun is a renewable source of energy. Let us be very particular about the use. Then Khadija is saying, we will study about the generation of energy, mainly focusing on electrical energy. Okay. Karthik says about energy, types of energy. As the name says, it says towards green energy. So, of course, we will understand different forms of energy. We will understand how energy is produced, that is, electrical energy is produced, and specifically how we all, the entire world, should stop using non-renewable sources of energy and start using renewable sources of energy, green sources of energy. That is what the focus of the chapter is. So when we say green, that means something related to pollution will be there. And when we say electrical energy, then something related to what we studied in science 1, effects of electric current, that will be there. And you are right. Both of them will come together. Those two chapters will come together in this chapter and something more also. And this is what the chapter contains. Generation of electrical energy. This is the main focus of this chapter. How do we generate electrical energy? How do we produce electricity? So we will study different sources, methods, the principles underlying those methods, advantages and disadvantages of various methods of generating electrical energy. And once we have understood the principles, the methods, the sources, the advantages and the disadvantages, we will see or we will decide which way we need to go. And perhaps we are going to decide that we have to go towards green energy and nothing else. This is what the chapter will talk about. It's a long chapter. It has a lot of information. The theory is less, but the variation of the theory, the information is a lot. Are we ready? Can we begin? Okay, I can see your thumbs and I can also see your texts. What is energy? Answer is very clearly written on the screen. Can you explain it with an example? What is energy? It says capacity to do work. Explain with an example. Yes, correct. So whatever work we do, now Sandhya is saying riding a bicycle. Yes, riding a bicycle, or as Fiza is saying, getting water out of the well, that is pulling a rope. Every work, if it is running, if it is throwing a ball, everything needs energy. And sometimes we say it is capacity to do work. We also say it is ability to do work, because if there is no energy, nothing can be done. So it is ability, and the amount of work that one can do, as you rightly pointed out, all of you, depends on how much energy we have. So it is both the ability to do work and it is also the capacity to do work. Do you remember how we measure energy? What is the unit of measurement in physics, in science? What is the unit of measurement? We studied once again this in the last science chapter that we studied in Science 1, effects of electric current. याद करो, बताओ. Thank you. It starts with a J, joules, Joules. And if you need to measure the amount of energy that we are using at home, then we don't use joules, we use units, kilowatt hour, not joules, because joule becomes a small unit of energy. Good. What are the different types or forms of energy that you are aware of? Electrical. First that comes to Prachi's mind is electrical. Chand is saying tidal energy. I have no idea what it is. No, I know. I'm just kidding with you. Aarti is saying potential energy and kinetic energy. Okay. Chand is saying wind energy, sound energy. Havesh is saying sound energy. Karina is saying chemical energy. Very nice example, Karina. Prachi is saying mechanical energy. Yes. So when we say energy, the first thing that should come to our mind is the mechanical energy. And we have studied about the mechanical energy in much detail. We did that study in the last year, class 9, where we looked at potential energy and kinetic energy. Can you tell me, how do we calculate potential energy? What's the formula? M into G into H. Very good. How do we calculate kinetic energy? What's the formula? Half into M into V square. Good. But these are not the only types or forms of energy. There are more. Heat energy, of course. Again, in the last science chapter that we studied, we saw how when we were passing electric current, when the electric current is passing through a conductor, some of the energy is used, converted into heat energy. And we can also use it to make a heater. Heat energy is an example. Heat energy is a type of energy. Another example, another type is light. That is also a form of energy. This also we studied in the chapter effects of electric current. Light bulb. We are heating the filament so much, filament made up of tungsten, that it starts glowing light. Sound energy, of course. हमने देखा होगा ना, साउंड से शीशा भी टूट जाता है. We can feel the vibrations of the sound. Magnetic energy. This is also something that we studied in the previous chapter in Science 1. If we have light poles, then they repel each other. If we have unlike poles, then they attract each other. Anyway, if we have a magnet, it has lines of force, which is called a magnetic field. And yes, we also have electrical energy, which is the focus of this chapter. When I was making this slide, I'm being honest with you, I completely forgot. Yes, chemical energy also. Yes. Good. Two of you have reminded me about chemical energy, and Sandhya is saying nuclear energy. What is chemical energy? Can you remind me? Where do we see it? Give me an example of mechanical energy. Give me an example of heat, light. I've given you already examples of mechanical. No, mechanical I haven't given. Heat and light and sound I have given you. Magnetic I have given you the example. Give me an example of chemical energy. Chances when we cook, then light and heat energy is produced. Okay, then not when we cook, when we burn the fuel, then light and heat are produced. Okay. Alfia, what example have you given, beta? I'm finding it difficult to understand. Milk converting into curd is an example of chemical energy. No, it's an example of chemical change. Prachi says burning of coal is an example of chemical energy, or is it an example of release of chemical energy? Prachi's answer is closest to the question that I asked. So energy is stored in the form of chemical bonds between atoms and molecules in the molecules. Coal is a very good example where carbon atoms are bonded together. There are covalent bonds between the carbon atoms and coal is produced. And those bonds have energy. When those bonds break, then energy is released. That's what is called chemical energy. All of us know acids are very caustic. Acids are corrosive, not caustic, corrosive. Acid अगर किसी पे हम डालते हैं या फिर acid पे अगर कुछ गिर जाएगा, then it gets destroyed. Because the acid reacts with the other substance, the bonds are broken, new bonds are formed, and the entire process releases energy. And what is that chemical reaction called, which releases energy? Type of chemical reaction. This chapter is connected to so many other things that we have studied earlier. What is that reaction called, in which energy is produced, released? Exothermic reaction. Therm means heat. Exo means out. So something that is throwing the heat out, releasing the heat, is exothermic reaction. Good, Khadija. And another explanation example that Khadija has given is chemical energy is stored in natural gas, coal, and petrol. Yes, energy is there even in the bonds that are there between hydrogen and oxygen atoms in water. And if somehow if we manage to derive that energy, release that energy, maybe we will have a very clean fuel. If water breaks, it will produce hydrogen and oxygen, no pollution. Right now, we are not able to do it in a very effective, economical way. But again, coming back to different types of energy, electrical energy is what we are focused on. Always remember law of conservation of energy, which is energy can neither be created nor be destroyed, and transfer or transformation of energy. Energy can be transferred from one place to another, Energy can be transformed from one form to another. In our textbook, at the top of the chapter, please listen to carefully what I'm saying. At the top of the chapter, in the can you recall, there are two different questions that are asked. Three, I'm referring to two. The second one says, what are different types of energy? And the third one says, what are different forms of energy? Right? Strictly speaking, there is no difference between these two questions. Types and forms, they mean the same thing. If you look at the answer to this question in the guide will say that the two types of energy are potential and kinetic energy. No, there are only two types of mechanical energy. They are not the two types of energy. So if we change the question to what are the different types of mechanical energy, then the answer that is given in the guide is correct. Potential and kinetic. Otherwise, it's not correct. Types and forms of energy, they are one and the same. Then why are we studying so much about energy? So many chapters. If you look at your Science 1 textbook, there is one chapter dedicated to electricity, another chapter dedicated to heat, two chapters are dedicated to light. All are energy. And then in Science 2, there is this chapter. Why are we studying so much of energy? And this is related to the first question that we asked. What is energy? Why are we studying so much? Why do we need to know? Why is this so important? Okay, because work is done due to energy. So, yes, work is done not due to energy, work is done by energy, by using the energy. Complete your argument, Prachi. Complete your logic. Chances to understand advantages and disadvantages of energy and its very important source of life. Now Prachi has inverted the statement and she says energy is needed for work to be done. This is so much better, no? Right? And not just for work. Our entire life will not be possible without energy. The mere act of taking birth needs energy. The cells that are there in our body, they also need energy. Forget about our entire body. Individual cells need energy to do whatever they are doing. Whether they are doing something or they are dividing, whatever. Every single thing that is happening, every single action that is happening, every single work that is happening, it needs energy. So energy is required for living. We will not be able to live without energy. That is why we are focusing so much about energy. And then you were giving me examples of chemical energy. One example is such a simple example, such a silly example, but no one gave. Now, can you give that example? Chemical energy, right? Give a very common example of chemical energy. Where do we see that? Now that we say that living is not possible without energy, what is that simple example? Very good. It's the food we eat. The food we eat, food is made up of various compounds, molecules, and energy is stored in those. And that energy is released, it is converted into a different form in the process which is called respiration, Karthik, not digestion. It's part of respiration. Digestion is about breaking the food down, but converting and storing the energy in the form of ATP, adenosine triphosphate. Must have studied last year. It's part of cellular respiration, not digestion. With that in the background, what energy is, why we need energy, different forms of energy, let us start the current chapter, which very nicely is called Towards Green Energy. What are we going to learn? We are going to learn generation of electrical energy, how electrical energy is generated. What is the basic principle behind that? Also, what is the basic method? That is what we will try to do today in this session. Also, as we do whenever we are starting whenever we start a new chapter, we will take a tour of the entire chapter and understand what is uh, where different things are kept, where different things are there, where different content is there, and how content relates to the questions in the exercise and questions in the exam. Oh, the mention of exam reminds me, Palak madam would have told you that we will have a test on Saturday. Some of you will write online and some of you will come to the school and write. I hope कि कम से कम अब जो लोग रेगुलरली आते हैं स्कूल मिलते हैं उनसे कम से कम वो ऑनेस्टली लिखेंगे. So, first things first, generation of electrical energy. And when I say generation of electrical energy, some of the students should tell me, sir, you are repeating, we have already studied this. Which device do we use? Which device do we need to use to generate electricity? It is a generator. Told you we have studied this in science 1. It is a generator. Yes, no trick question here. So what is the principle? What principle is the generator based on? Do you remember? What is that principle? We revised it in the beginning of the class today. Now, come on, make a guess. I thought you will tell me this only. So, Prachi and Chand are saying right hand thumb rule. No. Right hand thumb rule gives us the direction of the magnetic field. Khadija, correct. The principle that we are talking about is the principle of or the phenomenon of electromagnetic induction, which is governed. The basic principle is the electromagnetic induction, and it is governed by the right hand rule, not right hand thumb rule, Chan. Be very careful. Right hand thumb rule is when we hold the conductor in our right hand such that our thumb points in the direction of the current, then the direction of our fingers tells us the direction of the magnetic field produced by the conductor. This is right hand thumb rule. That came much before the Fleming's left hand rule and Fleming's right hand rule. So we will always say Fleming's right hand rule and Fleming's left hand rule. We will not bring thumb into Fleming's rule. Try remember, tell me, how did we define electromagnetic induction? In a very, very simple way. And there is a question also related to this in the exercise, effects of electric current. Speak or type. Whenever there is a change in the magnetic field, if there is an electric conductor in that field, then an electric current is produced in that conductor. And we call this phenomenon as electromagnetic induction. Change in the magnetic field, induces a electric current. So electromagnetic induction. Very nicely, but something that we did not talk about in the when we were studying the previous chapter, and we must cover that also in the current chapter. Is there is another way we can say this, and before we look at the new way, another the detailed definition that was given in the textbook was when there is a change in the number of magnetic lines of force that are passing through the electric conductor, then that produces an electric current in the conductor. And we had discussed that instead of saying change in the number of lines of force, we can also say change in the magnetic field. So one part of the definition we had simplified. Another part of the definition we had not simplified. We had left it as electricity is produced, electric current is produced. Remember, if we go to the beginning of the chapter, if we go to the electric current chapter from last year, what do we need for an electric current? Yes, we need a conductor, but that's not enough. There is something else that is needed. पानी अपने आप तो नहीं बहता है ना. That something has to happen for the water to flow. Something has to happen for the electric current to flow. What is that thing? No, Alfia, it has got nothing to do with turbine. If you remember, ऊपर से पानी नीचे की तरफ आता है. If there are two bottles, correct, Prachi? We need a potential difference. The positive terminal is at a higher potential. The negative terminal is at a lower potential. So the conventional direction of the current is from the positive terminal to the negative terminal. So what we need is potential difference. So if we are saying that the change in the magnetic field is able to produce a current in the conductor, that means we are able to create a potential difference across the conductor. Potential difference हमने बनाया होगा, हमको नहीं पता चल. But the existence of the current proves that there is a potential difference. If the current is flowing from left to right, that means this is at higher potential. The left side is at higher potential. The right side is at lower potential. That is the meaning. And this simplification is given in the current chapter. If you look at the bottom of the first page, it says most of the electric power plants are based on the principle of electromagnetic induction. And then it says in the next line, whenever magnetic field around a conductor changes, the potential difference is generated across the conductor. And this potential difference causes the electric current, produces the electric current. Now, if you have the textbooks with you and if you have them open, next question you will be very easily answer. You will answer very easily. Who is this scientist who described this phenomenon of electromagnetic induction? I want the full name. 2 words. Michael Faraday. Michael Faraday. The same person that we studied in Science 1 is going to help us in Science 2 also. Yes, he's not going to trouble us. He's going to help us. Now, if I have been able to remind you about electromagnetic induction properly, tell me about this experiment. What happened? What did we do in this experiment and what happened? What was our action and what was our observation? And yes, all these things are required in this chapter. This is an experiment that we did, that we studied when we looked at effects of electric current. What we did in this experiment was we stretched a piece of wire, a conductor, onto stands, and we connected the ends of the wire to a galvanometer. The instrument that you see is the galvanometer. And we had a magnet. What we did was, first step, we kept the magnet stationary and we moved the wire. And we saw that electric current was produced. How did we know? The needle of the galvanometer moved. Second thing that we did, we kept the wire as it is. We did not touch the wire. We kept it stationary. We took the magnet and then we moved the magnet. Upar, niche, aage, piche, left, right. And when we do that, we saw again that the needle of the galvanometer deflected. It moved, proving that electric current was produced. And Chand had written, if conducting wire keeps on moving in a magnetic field, a current is produced. It's only part correct. So there were two parts to this experiment. If we move the wire, which is in the magnetic field, electric current is produced. If we move the magnetic field itself, then also electric current is produced. Do you remember this experiment? What did we do in this? What we did in the next experiment was, instead of taking a wire, we took a coil. A coil is a loop of wire. It's a loop of wire, round. Need not be circular. It's a closed loop. It is connected to the galvanometer. So it's very similar setup. But instead of a magnet, we have a solenoid coil, spiral, and it is connected to a battery. And we studied again in the previous chapter that when electric current passes through such a solenoid coil, magnetic field is produced, and that magnetic field is similar to the magnetic field of a bar magnet. What we saw in this experiment was, if we switched the power on, the switch that is there for the solenoid coil, then the needle of the galvanometer deflected. When we switch it off, then also the needle of the galvanometer deflected. That means when the current started, when the current stopped. That means when the magnetic field was produced and the magnetic field was stopped, electric current was induced in the coil. We took the same two things. We kept the switch closed. That means current is flowing. And then we moved. We moved the coil. When we moved the coil, current was produced. When we moved the coil in front of the solenoid coil. Also, when we moved the coil or the solenoid when we took them nearer to each other and further away from each other, then also current was produced. The same experiments, 4 experiments. What are the 4? First one, moving the wire, moving the magnet. Second one, switching the solenoid circuit on and off. Third one, moving the coil in front of the solenoid coil. Fourth one, moving the coil such that sometimes it is nearer and sometimes it is further away from the solenoid coil. And in all these 4 cases, we saw electric current was produced. Electromagnetic induction. So, how do we change the magnetic field? That is the question. And these 4 experiments gave us that answer. We are saying that whenever there is a change in the magnetic field, electric current will be produced. So how do we change the magnetic field? These experiments tell us that there is not only one method, there are 2 possibilities. Either we move the conductor, that is the wire or the coil, or we move the magnet, or in the other experiment, we move the solenoid. If we change the position of the conductor, then also current will be induced. If we change the magnetic field, then also current will be induced. And this is important to note. Because what we have studied so far in the previous chapter when we studied generator is we move the conductor. Remember, the armature moves. If I take you back to that diagram, the AC generator on the right hand side of the screen, the magnets were fixed stationary. The conductor was moved clockwise or anti-clockwise. Whichever way we want to move, that will determine the direction of the current. And anyway, in case of AC, half the time current will be in one direction, the other half it will be in the other direction. But what happens in big places, the generators that we studied, they are small. वो पोर्टेबल होता है, घरों में दुकानों में मिल जाता है. कुछ ज्यादा बड़ा हुआ तो मे बी फॉर द एंटायर बिल्डिंग. But do we get our electricity from a generator? No. Again, something that we studied last year. We talked about power plants. How power is generated in the power plants. वो कैसे फिर अलग लंबे लंबे मोटे मोटे वायर से it comes from the power plants to different cities and villages. It goes to a transformer, then it goes to a substation, then it comes to our houses at 220 volts, 5 amperes, 15 amperes. So in those places, the big places where power is generated for a large population, in those generators, we don't move the conductor, we move the magnet itself. कंडक्टर स्टेशनरी रहता है, उसके चारों ओर हम मैग्नेट को घुमा देते हैं. Slightly different. How? The principle remains same. Principle is electromagnetic induction. We have already confirmed that electric current is induced in the conductor by whenever there is a change in the magnetic field. And that magnetic field changes when we either move the conductor or we move the magnet. It is just easier to move the magnet than to move the conductor. Easily at a large scale, the big generators that are used in the power plant, we move the magnets. देखो यहाँ पे in this picture, the magnet is being rotated. Can you see on the left hand side? Look at the diagram and tell me what is the direction of the rotation. Is it clockwise or anti-clockwise? So there is a bar magnet which is being rotated, and there is a coil. You can think of it as an armature. Instead of moving the armature, we are rotating the magnet. Because of the rotation, magnetic field changes. Because of the change in the magnetic field, electromotive force, the potential difference, is induced in the coil, which gives rise to the electric current. No chance, it is clockwise direction. देखो ऐसा है ना, just like our hands of the clock in the clockwise direction. अगर ऐसा होता तब एंटी क्लॉकवाइज होता. It's clockwise. So don't get confused. It's the same electromagnetic induction. The principle remains same. Now you can ask. Now I will ask. What is the other difference that you see in this diagram? There is one more difference. Yes, one difference is what is being moved. Another difference is something else. Very clear in the diagram. Tell me what is the difference. I will tell you why that difference is there. The other difference that you should have noticed is this instrument. Till now, very good, Khadija. Finally, no, Khadija is answering something else. So the instrument that we were connecting whenever we were talking about electromagnetic induction or generator was the galvanometer, or in one of the questions in the exercise, it was an ammeter. In this case, we are using a voltmeter. That's okay. Remember what we said? Current is induced because a potential difference is created. Potential difference can be measured using a voltmeter. So it is not necessary to use only the galvanometer or the ammeter. We can also use a voltmeter. This is just to confirm that yes, current has been produced. Because of that basic difference of rotating the magnet and not the coil, the construction of these generators are a little different. Now the inside of a generator, if we cut the generator, जैसे हम लौकी काटते हैं ना या करेला काटते हैं पूरा ऐसा, मान लो this is the लौकी and we are cutting it like this, and then we see क्या दिख रहा है, right? This is what we will see. This is called a transverse section. We see the magnet in the center. Again, compare it with the diagram of the other generator that we studied in the other chapter. Magnet used to be around the armature. Now, where is the armature now? We will not call it armature because we are not rotating it. Now it is the coil. Outside, circular. And we are rotating the magnet inside. So conductor is there, magnetic field is there because we have a magnet. And what kind of magnet it is? It is electric magnet. See the beauty of science. We are using electricity to produce electricity. We will use a little bit of electricity to produce a lot of electricity. So these are not normal magnets. These are electromagnets. Electromagnets are magnets that show magnetic property only when electric current passes through it. It will work even if we use normal magnets. We use electric magnets because we want very large, strong magnetic field. And we want to control the amount of magnetic field. Remember the video that we watched. If we increase the current, if we increase the turns in the coil, if we increase the speed of rotation, these are the things that affect the electric current. This is the construction. So now we have understood the basic principle, and we are getting to the basic construction of a commercial electric generator that is there in a power plant. But one question is still unanswered. How are we going to rotate this? Even in the general, in the smaller generator that we use in the shops, in the houses, we have to rotate the armature. And I remember Shubham Yadav had given us the answer: petrol, diesel, we will put there to rotate it. And yes, he was right. We have to rotate, whether we are rotating the magnet or we are rotating the coil, we need to rotate. Now, if we start using petrol, diesel and everything, then it will be very costly. It's going to be very costly. Also, it is going to be very difficult because these are not small generators. These are huge generators. These generators are as big as a 10 by 10 room or even bigger. Some of them are as big as our entire homes. So, human beings, we are smart people. We have designed another instrument, which Alfia already mentioned, which is called a turbine. A turbine is used to rotate. Rotate what? Rotate the coil or rotate the magnet in the generator. Basically, a turbine looks like this. It looks like a wheel with blades in very simple English. You see the wheel, the central part, the wheel, and you see the blades, just like a fan. Now you see the shaft here at the center of the circular disc. Now imagine this turbine, this piece connected to the magnet. Kaise? Yes. Going back to the previous screen. Now suppose at this center, this turbine, the shaft of the turbine is connected like this. So that means if we move the turbine, then it will move the magnet. And so it moves easily. Correct, Aman? If we try to move the magnet, अगर अपने हाथों से करेंगे, well, first of all, we should not do that. And it is scientifically, it will not help us because the generator is covered. The magnetic field, we want the magnetic field not to go out. We want to conserve the magnetic field. We want to keep it concentrated. So we will have everything in the inside a casing. The shaft will be projecting out, and that shaft is connected to the shaft of the turbine. So तुमको पता है ना कि if we have to open a डब्बा or something, so we use a lever, है ना? मैंने ऐसे करके खोलते हैं. Whether it's a chimta or the instrument which we use to cut the supari, these are all examples of lever, L-E-V-E-R. So this turbine also actually is a machine. It combines a pulley and a lever. Now, if we can move the blades of the turbine, then the turbine moves. If the turbine moves, then the magnet moves. If the magnet moves, then there is a change in the magnetic field, and that change in the magnetic field produces the electric current. If we move the turbine, then we will be able to move the magnet in the generator, and if that moves, electrical energy will be produced. Now the only question is, how do we move the turbine? And based on that question, based on the answer to that question, there are different types. There are different ways in which we can generate electricity at a commercial scale. That is what the chapter is about. This is what the chapter is about. Of course. So again, Hindi में कहते हैं ना कोहलू का बैल. So we put ox, we use oxes to grind a mill. That is possible. But imagine how fast the animal can do that. Can we use human energy, mechanical energy, our muscular energy to do this? Will we be able to move the generator 24/7? And of course, using petrol and diesel is not a very clean option. It's not a. It will, first of all, it's not a clean option, and also, second, it will take a lot of energy. It will take a lot of money to move the turbine using those fuels. So there are other ways of doing the same thing. Okay? At this point in time, what I want you to do is go through the pages of the chapter and find out what are the different ways that are given in the chapter that we are going to study of moving this turbine to produce electricity. Also, is there any other way given? Can we produce electricity without a turbine? Look at pages 48 till the last page of the chapter, which is page number 59, 48 to 59, and tell me, what do you find? How many methods do you find? And do you find any method where we can generate electricity without using a turbine? These are the two questions you are answering. Waiting for your answers. Let us look at the chapter together. So it starts with understanding of what energy is, that we use energy every day in our lives, whether we realize it or not. Even when we do something with ourselves, then also we are using energy. And all the devices, equipments that we use, they also use energy. Then it talks about the electromagnetic induction. It explains to us how the generator that we have studied so far is not what is used at a large commercial scale. We use turbines to move the magnet, which changes the magnetic field, and that generates electricity. This is the most important part of the chapter. And then the remaining part of the chapter talks about different ways of generating electricity. That is, different ways of moving the turbine. First point is thermal energy based electrical power station, जिसमें कि हम कोयला, we will burn coal, we will heat the water, and that steam will be used. देखो, steam turbine, the steam will be used to move the turbine. That is number one. You are counting, huh? One. So this is one type of diagram that you will see, which will be the process. The other type of diagram that you will see, which is there in the gray color, it says the energy transformation diagram. And these diagrams are there for each and every method that is explained in the textbook. These are important diagrams, both from understanding perspective, also from the exam perspective. These are asked. Also, these are a very nice, very short way of answering, remembering and answering. So this is steam wala, thermal steam. Very detailed schematic diagram of a thermal power plant is given. We will study that in detail. Don't worry. We said we will study about advantages and disadvantages. So when we say problems, they are the disadvantages. Now, power plant based on nuclear energy. Sandhya ne bola tha ye, nuclear energy. Nuclear energy is not chemical energy. Chemical energy is stored in the bonds, chemical bonds. Nuclear energy is stored in the nucleus of the atoms. The force between the protons and neutrons, the force that is keeping the nucleus together. When that breaks, when the nucleus breaks, energy is released. That is nuclear energy. So here also we have a steam energy, a steam turbine, but we are not burning coal. We are doing something else. We are using a nuclear reactor. Remember, we have started studying radioactivity last year. We will look at a good application of radioactivity this year. So this is number 2, nuclear. Same, our process and transformation, both are given. Now here I think the color is changed. Yes, be careful now. So schematic diagram of nuclear power plant is also given. Of course, there is a turbine. Once again, you don't need to worry. We will read, we will understand. You need to come prepared. Now it says energy of natural gas, third. And yes, जो मैंने आपको बार बार कहा, if you use petrol, diesel, natural gas, तो बहुत महंगा पड़ जाएगा. We don't use petrol and diesel, but definitely we use natural gas. Gas-based power plants are also there. Now the turbine is a gas turbine. How many we have seen till now? 3. Thermal, nuclear, gas. Then we are looking at hydroelectricity. Hydro is water. Water से electricity. Dams. Wind, you told, हवा से. 5th, उसमें भी टरबाइन होता है. ये देखो, gearbox, generator, shaft. Things are rotating. Wind turbine. I'm sure some of you would have seen this in real life. Tall
Windmill.
towers, windmills, yes. They were called windmills because they were used to grind stuff in the olden times. Now they are not used. Now they are used to generate electricity. Now, the next thing that is given in the chapter is electrical energy using solar energy. Let us see how that happens. Do we see any turbine? No. And you know that we use solar panels, solar cell, battery, inverter, electrical equipment. Where is the turbine? No turbine. Sixth. So in this chapter, in this textbook, we are going to study at least 6 different ways, methods of generating electricity, which all these 6 methods are used in life, in the world currently. Right? And out of this 6, only one is a method which does not rotate anything to generate electricity. What is that method? Now you can tell me. Some of you have already method. Solar energy, है ना? Solar energy, correct. We are just using the sunlight to generate electricity. Now, most important was the second question. Do you see any grouping of these different methods? The first was thermal using coal. Second was nuclear. Third was about natural gas. Then fourth one was hydroelectricity. Fifth one was using wind energy. And sixth one was using solar energy. Do you think there is any group, or do you think all 6 are all completely different? I see a group. Let us see if you find any group in this, any similarity or dissimilarity between these 6 methods. You know the answer. You have already used those words today in the class. If you paid attention to what all is covered in the chapter, coal, nuclear, natural gas, these are all non-renewable sources of energy. Water, wind, sun, these are renewable sources of energy. The name of the chapter is Towards Green Energy. We said we will understand how electricity is produced, what are the different methods, what is the principle, what are the advantages and disadvantages. And the name is Towards, means how can we move? I mean, when we do a comparative analysis, there is one section जो कि मैंने when we were I was taking you through the chapter, I deliberately did not mention. There is one thing that is in the chapter on page number. I'm telling you, you can open your textbooks and check. Page number 53. It's called Electric Energy Generation and Environment. This is where there is a switch from using renewable sources, non-renewable sources, to using renewable sources of energy. That is towards. And that section, whether we are using coal or we are using some nuclear source of energy, or we are using natural gas, what the disadvantages of these sources are, and how these disadvantages can be overcome by using renewable sources of energy, for example, water, wind, and sun. Tidal energy can also be used, but I'm not aware of any commercial use of tidal energy yet in the world. But yes, it is possible because tides are very regular, 2 high tides and 2 low tides in every 24 hours every day. So that rise and fall of the water level in the seas and ocean, that is also used to generate energy. Not just tidal, even the energy of the waves, they are also used, but not at a very big commercial scale. All those things are at an experimental stage. This is what our chapter is about.